Good morning, all of you. Students, today I am going to teach you about the electricity in class 10th. You know about the electricity, the branch of science which deals with about the nature of charges, or which deals with about the property of nature of charges, is known as electricity. So here you write here the branch of science, which deals with about the property of nature of charges, is known as electricity. So here we explain about the electricity means it is the property of charges which is explained through a science, through the branch of science about the nature of charges is known as electricity. There are two types of electricity. First, this is the static electricity. A static electricity, and second is current electricity. Current electricity. Here now we shall discuss about the definition of the static electricity. The branch of science which deals with about the property of the rest charge. Property of the rest charge is known as a static electricity. Means a static electricity. A static electricity. The branch of science which deals with about property of rest charge. Rest charge is known as a static electricity. A static electricity. So here, this is the static electricity. A static electricity explain about the nature of the or property of the rest charge or static charge. For example, glass rod rubbed with the silk cloth, then glass rod acquired the positive charge and silk cloth acquired the negative charge. Why the glass rod acquired the positive charge while the silk cloth acquired the negative charge? This is the reactivity series, means all the insulators which are arranged in the reactivity series. For example, this is the first element which is kept in first position in the reactivity series. This is the fur. Second is flannel. Third is this is the sealing wax, paper, etc. So we shall discuss about those insulators which is kept in the reactivity series. First two 16 elements means 16 insulators are arranged in the reactivity series in which first element rubbed with the second element, then first element is more reactive than the second element due to, for example, the fur is rubbed with the flannel, then fur react with the flannel means rubbed to flannel or fricted with the flannel, then the fur have tendency to lose the electron and flannel have tendency to gain the electron, and due to fur acquired the positive charge and flannel acquired the negative charge. For same example, for the glass rod rubbed with the silk cloth, then glass rod have the position in reactivity series in above with respect to the silk cloth, and due to this reason glass rod has tendency to lose the electron and the silk cloth has tendency to gain the electron, and due to glass rod acquire the positive charge and silk cloth acquire the negative charge. So here those branch of science which deals with about the nature or property of the positive charge means rest charge is known as static electricity. A static electricity. Now second is a current electricity. Current electricity. This branch of science which deals with the branch of science, which deals with about property of moving charges. Moving charges is known as current electricity. Current electricity. So moving electron, the flow of moving electron in a closed circuit is known as current, and the moving charges which property is explained by the branch of science is known as current electricity. So due to this reason, the scientists of the France, they have discovered in every element have only the two types of charges. The positive charge means a static charge, and the negative charge means current, means electricity. They have, so here we have write the reactivity series of the insulating elements. So there are two types of charges. First positive charge, second negative charge. It is discovered by the French scientists in every element. They observe that they rub together. Suppose that here the silk, there is a glass rod rubbed with silk cloth, then glass rod acquires positive charge where silk cloth acquires negative charge. Means we have taken the two pith ball and both pith ball brings near to the glass rod, then the charge transferred from the glass rod to the pith wall, the positive charges one by one. And when we have taken this pith wall, this is the positive charge, acquire the positive charge, then it repels to each other. So pith wall, which is, and this is the silk threads, silk thread. So here observe that, so when the glass rod rubbed with the silk cloth, then glass rod acquired the positive charge, while the silk cloth acquired the negative charge. While it acquired the negative charge, what is the reason of it? So I have written here the reactivity series of substances. Here the first substance, which is known as fur, and the last substance, which name is Gutta Parcha, means 16 substances are arranged in reactivity series, in which the first, which fur is more reactive than other all the 15 substances. Second, flannel is more reactive than the other the 14 substances. So suppose that glass rod is in 4th position and the silk cloth in 7th position. So glass rod rubbed with the silk cloth, then glass rod acquired the positive charge because it is a more reactive substance. They have tendency to lose the electron, and the silk cloth, which is below the position of the glass rod, then it is a less reactive in the reactivity series, then they have tendency to gain the electron, and due to this reason glass rod acquired the positive charge and silk cloth acquired the negative charge. Then these charges, we have taken this glass rod, they acquired the positive charge, then we have taken the ball, pith wall, and then this pith wall contact there, then it acquired the positive charge. It brings near. So two pith wall is charged from the glass rod, and when both are connected, means they have combined with the concrete support near to each other, then they are repelled to each other, means it shows the similar charges repelled to each other. Again we have taken the what? Two pith wall and this pith wall, which contact with the negative charge silk cloth. Then we observe that both pith wall acquire the negative charge, and when both are combined with the silk threads, silk thread, then we observe that they also repel to each other. It also shows the similar charge repelled to each other. When we have taken the one pith wall, this is the positive charge and other is negative charge, then they attract to each other, means here this is the repulsion, it shows the attraction, So here only there are two charges are present in every element, in every substances. It is verified from the scientist of the France, and due to this reason we have explained about the charge. There are two types of charges. So also we have defined the definition of the SI unit of the charge is Coulomb, and we define the unit of charge means 1 Coulomb. So here we explained about the 1 Coulomb charge. So you understand it here, the reactivity series. In this series, for example, paper rubbed with the silk cloth, then paper acquired the positive charge, silk cloth acquired the negative charge. When human body rubbed with the metals, then human body acquired the positive charge, metal acquired the negative charge. When the rubber rubbed with the resin, rubber acquired the positive charge, resin acquired the negative charge. When amber rubbed with the ebonite rod, then amber acquired the positive charge, ebonite rod acquired the negative charge. When the ebonite rod rubbed with the Gutta Parcha, then ebonite rod acquired the positive charge and Gutta Parcha acquired the negative charge. So it It depends the charging of any substance, any element according to their reactivity series. So when two bodies rub together, then it is necessary to one object acquire the positive charge and other acquired the negative charge. So this is the what types of two charges. Now we shall define the term of the 1 coulomb of charge. 1 coulomb of charge. Here 1 coulomb of charge. When two conductors which are charged from the similar charge, suppose that they are charged from the positive charge, or both conductors which are separated to each other through 1 meter distance. 1 meter distance. 1 meter distance in a space. So when two conductors they are placed in a space separated to each other through 1 meter distance, then both similar charges exert the repulsive force to each other. Exert the repulsive force to each other 9 into 10 to power 9 Newton. This may be positive charge, this may be negative charge, means similar negative charge. Similar negative charge separated to each other through a 1 meter distance in a space, then also they have a repulsive force exerted between each other. This force is 9 into 10 to power 9 Newton, then this charge is known as 1 coulomb of charge. Suppose that here the one conductor has the positive charge and another conductor has the negative charge, but they are separated to each other through a 1 meter distance in a space, and then also 9 into 10 to power 9 Newton exerts. This is the attractive force. This is the attractive force exerted 9 into 10 to power 9 Newton. That is known as 1 coulomb of charge. 1 coulomb of charge. Now we shall discuss about the properties of the charges. Properties of the charges. Properties of charges. Properties of charges. There are three properties of the charges. One, it has the additive properties. First, additive. Second, conservation. And third, quantization. Quantization of charges. Quantization of charges. There are three properties of charges. Property of charges. One is additive nature. Means charges are the resultant charge. Means additive means when the two or more than two charges are added, then it obeys the sum of the simple algebra. Algebraic sum of the charges is equal to resultant charge or net charge. So net charge is equal to what? Q is equal to first additive. Q is equal to Q1 plus Q2 plus Q3 plus dot plus Qn. So it shows the first additive nature of the charges. Means it does not obey the vector algebra, it obeys the simple algebra, and net charge is equal to the summation of the individual charges. Net charge is equal to the summation of the individual charges. Suppose that Q1 is equal to 2 coulomb, Q2 is equal to 1 coulomb, Q3 is equal to 2 coulomb, then 1 plus 2 plus 1 plus 2 is equal to 5 coulomb charges. So they are added the charges simply way according to the obey of the simple algebra. Now second is the conservation. Conservation of charges means charge neither be created nor be destroyed, only transferred from one substance to the another substance and total amount of charges remains constant, means isolated charges remains constant, is known as law of conservation of charges. Law of conservation of charges. For example, here we shall take an example. For the second case, you have taken the uranium 92 and 235 plus added 0 1, then it fused and formed the barium plus krypton plus 3 neutron plus energy here. So barium 56 36, we know that uranium has the atomic number is 92, then it has the 92 electrons. Now here it is breaking, means fission, means breaking by the slow moving of the neutron, its nucleus. Then it formed the 3 new elements, barium plus krypton plus 3 neutron plus tremendous amount of heat energy and light energy. So barium, atomic number of the barium is 56. The atomic number of the krypton is 36. So here the atomic number also shows the number of the electrons, number of the protons. So here number of electrons is equal to 56 plus 36 plus 0 is equal to 92. So it obeys the law of conservation of charges, means charges neither be created nor be destroyed, only transferred from one substance, one element to the another element, and total amount of isolated charge remains constant. So it is known as the law of conservation of charges. Third, quantitation of charge. Quantitation of charge means third here. Third is quantitation of charge means the multiple integral of charges. Total number of multiple integral of charges means net charges is equal to multiple integral of charges is known as quantitation of charges, means here the Q is equal to NE. Q is equal to NE. Here the where N is equal to plus minus 1 plus minus 2 plus minus 3 dot dot dot, and E represent the basic charge. Basic charge, its value is 1.6 into 10 power minus 19 coulomb. Q is equal to NE means N is equal to plus minus 1 plus minus 2 plus minus 3 is equal to basic charge 1.6 into 10 power minus 19 coulomb. So here this is the first formula. Then N is equal to number of electron is equal to Q by E, second formula, and here U is equal to E is equal to Q by N. This is the third formula. So we can find also the numerical value or the value of the number of charges. Now here we shall discuss about the one question according to the quantitation of charges. Question number first: how many electrons flow in 5 coulomb of charges? 5 coulomb of charges. So here we understand about the quantitation of charge. Q is equal to NE. Then N is equal to what? Q by E. Here is given here. Q is equal to 5 coulomb. E is equal to 1.6 into 10 power minus 19 coulomb. So putting the value of Q is equal to 5 coulomb by 1.6 into 10 power minus 19 coulomb, then we get here 5 into 10 power 19 by 1.6 decimal, then we get here 10. Now here we have get the 50 by 16 into 10 power 19 is equal to 3.1 to 5 into 10 to power 19. So n is equal to what? 3.125. So we can find the value of it, and after that we shall discuss about the electric potential. Electric potential. Here electric potential means, suppose that here the positive charge, it is also known as test charge. When the positive charge brings from infinite to that point A, means when the charge brings from infinite to that point A against the electrostatic force without any acceleration, that is known as potential of a current. Means when the positive charge brings from infinite to that point against electrostatic force without any acceleration, that is known as electric potential. So here electric potential is equal to work done by unit charge. So here work done, which is denoted by W, and charge denoted by Q. So the work done to bring the unit positive charge from infinite to that point A, then it is known as electric potential. So it is denoted by V is equal to W by Q. Its SI unit is joule, but a coulomb is equal to volt. So here the electric potential, which is also measured in instrument, is known as voltmeter. Voltmeter is connected in closed circuit in parallel combination. Now we shall discuss about the electric potential difference. Electric potential difference means when suppose that this is the A and B, here the positive charge, when the positive charge brings from, or the work done to bring the positive charge from B to A, the work done positive charge from B to work done to bring the positive charge from point B to A, then its potential is differ from between point B to A is called its potential difference. So always the charges flow from higher potential to lower potential. So here potential is differ between the 2 point B to A. Suppose that charge plus unit charge is kept at point A and it moves from point A to B, then its potential is higher at point A and lower at point B. But when the charge plus which is kept at point B and it moves from point B to A, then its potential is higher at point B and lower at point A. So the potential difference between the 2 points when the unit positive charge which work done to bring from the point B to A is known as its potential difference. So here VAB is equal to WAB by Q, or VBA is equal to WBA by Q. Its unit is also potential difference, as like a potential means volt. As unit of the potential difference is volt. So here we have discussed about, so potential difference is also measured from an instrument is known as voltmeter. It is also connected in the circuit is in parallel combination. Now we shall discuss about the electric current. The flow of charges per unit time taken in closed circuit is known as electric current. The flow of charges per unit time taken in closed circuit. Circuit is known as electric current. It is denoted by I. Then I is equal to flow of charges means Q by time t. You have also learnt this is the formula for the first I is equal to Q by t. Second formula. So we put also the here I is equal to NE by T because here Q is equal to NE. So putting the value of Q in equation first, then we get here I is equal to NE by T. Second formula, Q is equal to what? IT, equation second. And third is third formula. Third is what? T is equal to what? Q bate I. This is the third formula. And this is the fourth formula. Fourth, ये third, this is third, and it is a fourth. So flow of charges per unit time taken is known as electric current or moving current, means this is the dynamic current. It is also known as dynamic current because it has motion. So flow of charges means flow of electrons because the positive charge means proton does not flow. So flow of electrons per unit time taken is known as electric current. Now here this electric current is measured by an instrument which name is known as ammeter. Its full form is known as ampere meter. So ampere meter in closed circuit is connected in series combination. So here we shall discuss about the instruments which is used in the measurement of the current. It is known as ampere meter. Ampere meter means this is the ammeter. Ammeter means ampere meter. Now very small current measured through a instrument, it is known as galvanometer. Galvanometer is used to measure the below the ampere, means milliampere, microampere, but the ammeter does not measure the milliampere and microampere. It starts to measure from the ampere. So 1 ampere is equal to 10 power 3 milliampere. 1 ampere is equal to 10 power 6 microampere. So we shall discuss about the electric current. Now we shall discuss about the another topic, how to get continuous flow of current. How to get continuous flow of current. How to get continuous flow of current. We know that the current flows between 2 ends of the wire through the difference of the potential. Potential is differ between 2 points. Then the current flows. For example, we have taken a battery. This is the positive, negative battery, and when it is connected with the connecting wire with bulb, then bulb glows because the current flows from the positive terminal to the negative terminal in outside and inside from the negative to positive. So this current which flows from the positive terminal to the negative terminal outside the cell, then it is known as conventional current. The current which flows from the negative terminal to the positive terminal of the circuit, or negative terminal to the positive terminal in a closed circuit, then it is known as actual current. So here the conventional current flows from the positive terminal to the negative terminal, means conventional current flows from the higher potential to lower potential, but actual current flows from the lower potential to higher potential, means negative terminal to the positive terminals. Negative terminals to the positive terminals. Now we shall discuss about the electric circuit. Electric circuit. Now this is the battery connected with closed switch with bulb, negative, positive. So here electric circuit, the electrical appliances, all the electrical appliances connected through the connecting wire in a closed path. In a closed path is known as electric circuit. Here battery, the switch, bulb and connecting wire. All are connected. Electrical appliances all are connected in closed path, then it is known as electric circuit. Now here we shall discuss about the electric circuit, and when all are connected, then it is known as also electric diagram. So all the electrical appliances connected systematically one by one through a connecting wire in closed path, then it is also known as electric circuit. And after drawing diagram, then it is known as electric circuit diagram. Now we have discussed about the symbols of electrical components. Electrical components. First, this is the cell, battery, electric wire, a joint wire, crossing wire, resistance, fixed resistance or resistor, resistors, variable resistance or rheostat and rheostat. Volt ammeter, voltmeter, galvanometer, etc. So here, this is the symbols of the electrical components. One things is a conductor and insulators. We have discussed also, you have learned in lower classes also, those substances in which electric current passes easily way or they conduct the electricity is known as conductor, or those substances which have very low resistance, due to it flow the current or the easily way the electrons flow through it easily way, or electric current flow easily way, then it is known as conductor. For example, silver is the best conductor of electricity, while all the metals are good conductor of electricity. But insulators, those substances in which electric current does not pass easily way, mean those substances which have higher resistance and due to electric current does not pass it through it, means electrons, the flow of electrons not move from one point to another point is known as insulator. For example, dry wood, plastic, rubber, the bakelite, their paper, dry paper, all are an example of the insulators. So thank you.